Now let us see this problem. This is again a very simple problem if you know what is de Broglie wavelength, right? A proton is fired from very far away towards the nucleus with charge Q is equals to 120 E. There is a proton, it is having an electronic charge E. Now there is a charge with 120 E, where E is the electronic charge. It makes a closest approach of 10 FM to the nucleus. The de Broglie wavelength of the proton at its start is, right? So basically initially it was very far away, that means at an infinite distance. Now since it is very far away, potential energy will be zero, U will be zero at this point, right? U will be zero, not delta U, rather U will be zero, and kinetic energy will be there, which will be equals to half mv square. And finally at the distance of closest approach, when it is 10 FM, what is happening is at distance of closest approach, its velocity should become zero, otherwise it should be still moving, right? The velocity should be zero, but now there will be an energy, potential energy U2, which will be equals to K Q1 Q2 upon R, which is Ke into 120 E upon R. This is 10 raised to the minus 15, right? This is U2, and Ke2 will be equals to 0. Now using conservation of energy, total energy at one point should be equals to total energy at the second point. This implies that half mv square should be equals to, because total energy, that means kinetic energy plus potential energy is 0, and at final point total energy will be kinetic energy plus potential energy is 0, so that will be equals to K into 120 E square divided by 10 raised to the minus 15, and that means velocity V will be given by under root of K into 120 E square divided by into 2 divided by of M into 10 raised to the minus 15. So it is asking de Broglie wavelength. Lambda is given by H upon mv. This will be given by H divided by of under root of mv. That means m will go inside and it will be multiplied in the numerator, K into 240 into E square divided by of 10 raised to the minus 15, right? So E square, it is an under root, we can take H upon E, E as common, so E, and we can put the values now. MP is given by 5 by 3. Let us solve it over here rather than solving over here. So this will be given by H upon E. H upon V value is given as 4.2 into 10 raised to the minus 15 divided by of under root of 9 into 10 raised to the power of 9. This is K into 240, right, into mass M, which is given by 5 by 3 into 10 raised to the power of minus 27 divided by of 10 raised to the minus 15, right? So now if we solve this, what we will get, this 3 can cancel out, this will be 3, and 240 into 5 is 1200, 1200 into 3 will be 3600. So 4.2 into 10 to the power minus 15 divided by of under root of 240 into 5 is 1200, 1200 into 3 is 3600, 3600 into 10 raised to the minus 15, 10 raised to the minus 12, and it will be 10 raised to the minus 12 and 9, right? It will be 10 raised to the minus 4, and it will be 10 raised to the minus 2, 10 raised to the minus 1. That means 4.2 divided by of 3.6, sorry, 4.2 divided by of 0.6 into 10 raised to the minus 15 will be the answer, right? So this will be 7 into 10 raised to the minus 15. This is the wavelength. Now if you see over here what it is asking the de Broglie wavelength in units of FM. That means FM is this thing only, so that means the answer will be 7 FM, right? So the correct answer is 7. This was another easy problem which you might have practiced a lot many times while you were preparing yourself.